Okay, so we're going to do question 4.5. So it's giving you 3 consumption bundles. So we got bundle consumption bundle A, including the consumption amount BA and the consumption amount C of CA. Okay, consumption bundle B equal to BB and CB. In consumption bundle C, where it's consumed B C amount and C amount. Okay. So they say A. So the preferences A is weekly prefer. Consumption bundle A is weekly prefer to B, and the consumption bundle B is weekly prefer to C. Okay. So part A asking you for there to be a unique ordering of the preferences, what must be true about the comparison between A and C. So in order for us to have a unique ordering of preferences, then we know that the transitivity property has to apply. Okay, so in other words, if A is weakly preferred to B and B is weakly preferred to C, then A has to be weakly preferred to C. Okay, so that is the transitivity property of the preferences. Okay, so I would say for there to be a unique a unique order of the preferences, then the transitivity property it has to hold, which means that if A is weakly preferred to B and B is weakly preferred to C, then A has to be weakly preferred to C. So this is the relationship between A and C. Okay, so A has to be weakly preferred to C. Okay, so in part B, it's asking you to sketch 2 diagrams indicating the preferred set of C and B in the 2 cases. Okay, so we're going to do the first case. So first of all, we would like to draw the preferred set of B and C first, and then we are going to allocate bundle A in a different case. Okay, so I got C over here again, and I got B over here, have 0. Okay, so when we talk about the preferred set, we're talking about the indifferent curves. Okay, and all the bundles on the indifferent curves are going to be equally preferred. All of the bundles below the indifferent curve is going to be preferred to, and all the bundles above the indifferent curve is going to be better than all the bundles on the indifferent curve. Okay, so for example, I have a well-behaved preference where the indifferent curve is going to be just a convex curve like this. Okay, so this is my indifferent curve. Alright, so I just say I have a bundle bundle C over here. Okay, on this. Now I would like to draw the preferred set of C. Okay, so the preferred set of C is going to include all the bundles that are going to be preferred to bundle C, okay, which is basically better than bundle C. So anything above the indifferent curves in the interior set is going to be including all of the preferred bundle to C, and that is called the preferred set of C. Okay, so that is going to be including all of these. Everything that is above the curve. Okay, so I will say this. Okay, so that is called the preferred set of C. Okay, and now I'm going to draw an indifferent curve corresponding to bundle B and also find the preferred set of B. Okay, so we know that bundle B is including, bundle B is weakly preferred to bundle C. Okay, so it has to be lying on a higher indifferent curve, or at least in the preferred set of C. Okay, so it can't be in this area. It can't be below the indifferent curves. So for example, I just do a quick. I would say I have another indifferent curve over here. Okay, indifferent curve 2, this one, and I would say I have bundle B over here. Okay, so this bundle B over here is in the preferred set of C, which is satisfying the requirement in the questions. Okay, and so I would like to indicate the preferred set of B, which is including all of the bundles that are preferred to bundle B. So that is, again, it's just going to be all the bundle in the interior area, which is basically above the indifferent curve 2, that is corresponding to bundle B. Okay, so alright, so over here I would say so in the yellow area is the preferred, so this is the preferred set of B. Okay, and with the yellow thing, this is the preferred set of C. Okay, now in the first case, we would like to draw bundle A such that it lies in the preferred sets of both and B, of both B and C. Okay, so as you can see, the intersection between the yellow area and the black light area is going to be the area that including all the bundles that are preferred to bundle B and C. So if I just plot a bundle A somewhere here, okay, so as you can see, bundle A is now preferred to both the bundle B and C, and so therefore it is lying in the preferred set of both B and C. Okay. Now, so the second case is asking you to plot bundle A such that it lies in the preferred set of B but not in the preferred set of C. Okay, so as you can see from the diagram over here, if we got two indifferent curves that are not intersecting each other like this, then it's not possible to have bundle A that is in the preferred set of B but not in the preferred set of C, because B is preferred to C. Okay, so if B is lying on a higher indifferent curve like this compared to C, then whenever A is in the preferred set of B, it is going to be in the preferred set of C. Alright, so if we have a case where the two indifferent curves are not intersecting each other, then it's not possible to have such a bundle A. Okay, so therefore, in order for bundle A to lie in the preferred set of B but not in the preferred set of C, then we will have to draw the two indifferent curves that are cutting each other in order for such a bundle A to exist. Okay, so I'm gonna show you in a little diagram over here. So what I got is just going to be similar to before, where I have C over here, I have B here, I have 0 here. Okay, and I have also an indifferent curve, say indifferent curve 1, where okay, and where this is my bundle C. Okay, and I got another indifferent curve, say something like this. Okay, and this is my indifferent curve 2, and I'll just say this is my bundle B. Okay, so as you can see, bundle B is preferred to bundle C, which is consistent with the information from the question. Okay, because B is higher than C. So as you can see, bundle B including a higher amount of B and a higher amount of C. So basically, bundle B, as you can see, obviously is preferred to bundle C. Okay. So again, the preferred set of C is just going to be the area that is including all the bundles that are preferred to C. So in this case, again, it is just going to be the whole area above the indifferent curve going through point C, which is just going to be the yellow highlighted area over here. Okay, so it's all of these area that is above the indifferent curve. This is the preferred set of C. Okay, and again the preferred set of B, I will just going to use the black line, which is something like this. Okay, so anything above the black line, the black indifferent curve that is going through B is going to be the preferred set of B. Okay, which is all the black line area. Okay, so I want to plot bundle A such that it is in the preferred set of B but not in the preferred set of C. So something like this. Okay, so if bundle A is somewhere here, as you can see, it is inside the black light area, but it's not inside the yellow shaded area. So that is satisfying the requirement. Okay, so as I said before, in order for such a bundle to exist, then the only way to do it is for the two indifferent curves to cut each other. Okay, and this is the case where our transitivity property doesn't hold. Okay, so as you can see, bundle A is so bundle A over here is preferred to bundle B. Okay, because it's in the preferred set of B. So it is preferred to bundle B. Okay, and bundle B is preferred to bundle C because bundle B is in the preferred set of bundle C. Okay, however, bundle A is not preferred to bundle C because bundle A is not in the preferred set of bundle C. So in this case, the transitivity property doesn't hold. Okay, and so that is the reason why the two indifferent curves are cutting each other. Alright, now this is the case where our unique ordering of preference doesn't hold, and so therefore it doesn't represent a preference relation. Okay, so this is just basically an example to show you that the sort of transitivity property is going to ensure that we have a proper unique ordering of preferences, and we are going to have a proper preference relation, and it's going to ensure that the two indifferent curves are not cutting each other. Okay, so that is the reason why whenever later on when you draw a different curves, you will have to draw them parallel to each other, never cut each other, because if they do cut each other, then we do not have a proper preference relation where the transitivity doesn't hold. Okay, and we do not want that in our preference relation. We want a transitivity property and we want a unique ordering of preferences. Okay, so therefore we have to make sure that when we draw indifferent curves, they are not cutting each other. Okay, so in this case I'll say okay, so transitivity doesn't hold. Okay, because A is preferred to B. Okay, because A is in the preferred set of B. Alright, so in the black light area, which is the preferred set of B. Okay, and also B is preferred to bundle C, because as you can see, B is in the yellow shaded area, which is the preferred set of C. Okay, however, the bundle A is not preferred to bundle C because A is not in the preferred set of C. Okay. Alright, so therefore this is the case where it doesn't represent a preference relation. Okay, so we do not have a unique ordering of the preferences. Okay, and so we got no preference relation. Okay, so not a well-behaved preference relation, and so therefore the two indifferent curves are cutting each other. Okay. Okay, so remember, this is just an example to show you that is the reason why we do never want the two indifferent curves are cutting each other. Okay, to cut each other, because we want to have a proper preference relation, and we want to have a transitivity.